Hello, I'm Nick, and I'm going to show off the work I've done this week on my game slash like engine changes. Basically, my idea with making the game um, was I wanted to discover the flaws in the engine right now by just making a game because it just seems like a good way. And I went with a rhythm game just because I like rhythm games and I would find it valuable for my engine to have the correct features to make a rhythm game, and we'll discuss like what I needed to change in order to make this happen and changes that are still ongoing. Just basically want to give an overview of the game right now. So we have the menu, we can start, and I will explain how it works, although the features aren't completely here right now due to the uh, lack of audio API working. But basically, we have a player. If you've seen a game called Crypt of the Necrodancer, it's going to be hopefully similar to that, um, but with a twist, which hopefully I'll be able to develop in the next week. So we have these enemies here, and they're basically just going to try to follow us along the grid as the beat progresses. So I have them set right now to like every 4 beats, they're going to take the closest square to get to your position. And I posted a like a GIF a while ago showing this audio BPM tracker. It's just a visualizer, so the player can actually visually see when it's okay to move. Because the idea is you're only supposed to be able to move on the beat, or at least once per beat. And there's a nice position manager I have that prevents enemies from overlapping, and enemies won't like try and move onto the same square as the player, and like when an attack will trigger. A lot of the logic is inspired by Crypt of the Necrodancer. So lots of like analyzing that footage, seeing how their system works, and seeing how I can use that. But hopefully a lot of the combat and stuff is going to come next week. But the framework for everything is pretty much there now. Right now, the game is actually broken because I'm in the process of redoing the audio API after finding problems with the previous one I had implemented. So basically, we had the original audio API be created for homework 7, I believe. That ended up not being good enough for my use cases because if you have any experience making a rhythm game, you need very precise audio tracking. So you need to be able to tell when the beats are in the song precisely. The problem is, with many audio systems, especially ones in default engines like Unity and Godot, Unreal, there is some audio latency that happens. So the audio will actually be playing, and if you started a timer at the same time the audio was playing, the audio does not play back at like 100% speed because there's some small staggers and glitches that happen in the audio playback, so it gets delayed, and eventually it like slows too far back, and eventually it just gets way off sync. So basically this means I needed a way to track the actual amount of data that is being processed through the audio file to get the precise time in the song we're at. So that's what I'm in the process of doing right now. It pretty much works. I'm right now getting it to a point where I can play multiple audio tracks, but shouldn't be that difficult. I have it playing one right now. And I did have the game working more. SDL Mixer does have the ability to do this, but only for one audio file, which is a little strange. So I needed to implement my own with multiple, and it was interesting to learn about how SDL's audio backend works. So yeah, we can get into the audio API a little bit here. It's pretty simple, and not all of these functions are implemented. The important ones are like loading the file and this audio callback. So loading a WAV file is slightly different than in how we did it in Project 7. It's a little more complex. We basically have a file path that's the same, but we are directly getting the audio spec, the a buffer, which is just the actual sampling data of the audio and the length of the array that holds all the sampling data. And a sample of an audio, if you don't know, is just, it's basically the way it's represented is it's just an array of like amplitude values, and they'll play at like a constant timing. So then you get different pitches and different volumes depending on the values inside of the array. The most interesting thing is actually this callback function. This is the hardest part because every time SDL wants to play audio, it's going to take this callback function and we have to feed it in the audio data. So this took the longest to figure out. Basically, there's this callback and it gives us user data, which is just like, extraneous data we can keep or, pass through if you need some extra data. The actual audio stream, which this is what it's going to play, and the length of the stream. So we start by like setting it to 0 to clear like the last bit of audio from the stream. Then there's basically some logic here to fill up the stream. So anyways, that's the audio API. It's actually been kind of fun to figure out how all this works. Get a bit deeper into like, how sound files work or audio files work. But that is probably where most of my effort has gone in this endeavor. Besides the actual game, the game has taken a bit to develop. Some other small changes I made was I redid the how rendering is done, because I realized that the way we had rendering set up was extremely not conducive to doing things efficiently, especially with UI and text, because the way we were rendering UI is, imagine if I want the button to be rendered in the center of the screen, we need to first figure out where the top left of the button is, where we want it to display, and then figure out like halfway measurements of the button, and you better hope the button is an even number of pixels or you're going to have problems. Anyways, I just basically took the screen space portion of our rendering and applied it to UI and text. So it doesn't follow the camera, but I can now render like at 0, 0, and I think that's where the panel, this back blue panel is, for example. And it will automatically center itself, and the center of the panel will be, the location of it, not the top left. And that's just a much more intuitive way to develop like UIs and stuff.